Okay, now we are going to convert, we're doing number 12, we're converting 1 inch squared to centimeters squared, and it gives us a conversion factor of 1 inch equals 2.54 centimeters. All right, so we want to write down what we're looking for. We're looking for centimeters squared, and write down what we're given, which is just 1 inch. And remember in class he said to write it out separately. So 1 inch times 1 inch. And it might seem like that's a lot of work, but it really does help. All right, so on the bottom, if we want to get rid of one of the inches, we can write our conversion factor, which is 1 inch for every 2.54 centimeters. And then we're going to do that again because we only got rid of 1 inch, right? So I can cross off 1 inch, one of the 1 inches. And then we want to do that again, 2.54 centimeters. And that allows us to cross off the other inch. And that leaves us with centimeters times centimeters, which equals centimeters squared. So we'll go over to our calculator. And we will do 2.54. We can just square it. We get 6.4516. All right, but how many significant figures are in our original problem? We have 3 here, and we don't count these because that's a known measurement. So this we don't consider when we're considering significant figures, just this one. So that's 3 sig figs. So I'm going to rewrite our answer, and we're going to find 3 sig figs. So we need 1, 2, 3. Look at one more. And that gives us 6.45 centimeters squared. All right. Our next problem is going to be a specific heat problem. And so I'm going to walk you through this one slowly and give you some tips for these. So the problem says how many joules of energy? So we know what we're looking for. We're looking for joules of energy. Are required to raise the temperature of 150 grams of water. We have a from temperature, and in fact, let's do that in a different color. We have a from temperature, and we have a to temperature. So from a temperature to a temperature. Okay. So our specific heat equation is Q, and Q is our joules. That's Q equals joules. That's like our energy. And then we have M, which is our mass. We have C, or I write it SH, which is our specific heat. And then we have this change in temperature. And hiding in this little triangle is another equation. So there's like an equation hiding in that triangle. And that equation is our final temperature minus our initial temperature. And that's why I highlighted them in different colors. So when you see the word from, that's your initial temperature. We're going from this temperature to another one. So from means initial and to means final. My next piece of advice is to write down all of your variables. All of the variables from this equation, write them down, and write your change in temperature as initial and final. And we're just going to go through and we're going to write the numbers next to the variables. So we know that we are trying to find Q. We're trying to find the energy. The mass was 150 grams of water. You have to have specific heat for water memorized. It's 4.18 grams per joules. I had that mixed up, sorry. Joules per grams degrees Celsius. And then our initial temperature was 15 degrees Celsius, and our final was 45 degrees Celsius. And now you just plug these in. You just plug and chug. So we know we're looking for Q. we have M times, we have our specific heat. This one is known to us. You only have to know water. Anything else he'll give you. And then we have our hidden equation right here. Now you can either do the math beforehand or you can just plop it into your equation. So I'm going to do T final, which is 45 minus 15, which is my initial. Then we're going to go over to our calculator. And here's another good time that you want to utilize your parentheses. Okay, so we had 100, utilize your parentheses. 150 grams of water times 4.18. And that's going to give us an answer. And then I'm going to do my temperature separate because that just is better for my brain this way. So I'm going to do 627 times that change in temperature. And I'm going to get that big number. So our Q equals that big number, 18800. Wait, what was that number? 18810. All right, 18810 joules. Now, this isn't our final answer because we need to go to specific figures. So in our problem, we have, what is this? 4, 3, 3. So we want to do 3 significant figures. So I'm going to look at the first 3 that I need. I'm going to look at one more. That one doesn't change my 8, so I'm going to write my Q as 18800. These numbers are not significant, but they're placeholders. They're important, so we need to put zeros there. And that's in joules.